Alright, so in this problem, I have 8 to the power of x is equal to 80. So I'm going to first start by rewriting 80 as 8 times 10. So now I have 8 to the power of x is equal to 8 times 10. And now I'm going to go ahead and divide both sides by 8. So then these two cancel out, and I get 8 to the power of x over 8 is equal to 10. Now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So a to the power of x over 8, well, 8 is the same thing as a to the power of 1. So I get a to the power of x minus 1 is equal to 10. Now, 8 I can rewrite as 2 to the power of 3. So now I have 2 to the power of 3 to the power of x minus 1 is equal to 10. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 3 to the power of x minus 1, that's going to equal 2 to the power of 3 times x minus 1. And I can simply distribute the 3, so I have 3 times x plus 3 times negative 1. So 3 times x is 3x, and 3 times negative 1 is negative 3. So I have 2 to the power of 3x minus 3 is equal to 10. Now I'm going to take the log on both sides, so I'll get log of 2 to the power of 3x minus 3 is equal to log of 10. And if I have something in the form log a to the power of b, I can move this exponent b to the front, so this is going to equal b times log a. So in this case, b is 3x minus 3, so if I move this to the front, I get 3x minus 3 times log 2 is equal to log 10. Now, log 10, that's actually equal to 1. So now I have 3x minus 3 times log 2 is equal to 1. Now, if I divide both sides by log 2, these two cancel out, and I get 3x minus 3 is equal to 1 over log 2. Now if I add both sides by log 3, these two cancel out, so I get 3x is equal to 1 over log 2 plus 3. And 1 over log 2, that's the same thing as 1 over 0.301 plus 3, which is equal to 3.3223 plus 3. So I have 3x is equal to 6.3223, meaning x is equal to 2.1074. Alright, so in this problem, I have 2 to the power of x plus 8 to the power of x equals 68. So I'm going to first rewrite 8 as 2 to the power of 3. So now I have 2 to the power of 3 to the power of x is equal to 68. And I can actually switch these two. So I get 2 to the power of x plus 2 to the power of x to the power of 3 is equal to 68. Now I'm going to let 2 to the power of x equal to the variable y. So now I have y plus y to the power of 3 minus 68 is equal to 0. And this is the same thing as y to the power of 3 plus, I'm going to write y as 17y minus 16y minus 68 is equal to 0. And now I get y to the power of 3 minus 16y plus 17y minus 68 is equal to 0. So I simply switch the places of 17y and negative 16y. And now from y to the power of 3 minus 16y, I'm going to factor out y. So I get y times y squared minus 16 plus from 17y minus 60, I'm going to factor out 17. So I get 17 times y minus 4 is equal to 0. And it's the same thing as y times y plus 4 times y minus 4. That's equal to y squared minus 16 plus 17 times y minus 4 is equal to 0. Now if I factor out y minus 4, I get y minus 4 times y plus plus 17 is equal to 0. And this is equal to y minus 4 times y squared plus 4y plus 17 is equal to 0. So now this gives me two equations. I get y minus 4 is equal to 0, and y squared plus 4y plus 17 is equal to 0. So for y minus 4 equals 0, y is obviously equal to 4, so I get one solution. And from y squared plus 4y plus 17 equals 0, you have to use the quadratic formula to solve this. And if you actually do end up using the quadratic formula, I'm not going to do it because it's a waste of time, but you get that there is no solution, but because you get the square root of a negative number, and you can't take the square root of a negative number. So y equals 4 is my only solution for y, and now remember how we let 2 to the power of x equal to y. So now if I have 2 to the power of x is equal to y, and y is 4, that means I have 2 to the power of x is equal to 4. And 2 to the power of what number equals 4? 2, right? So I get x is equal to 2. And this is my solution to this problem. Alright, so in this problem, I have 2 to the power of x plus y minus 2 to the power of x is equal to 120. So obviously, I want to find the values of both x and y for this. So for my solution, I'm going to first start by using the property of exponents that states that a to the power of m plus n, this is the same thing as a to the power of m times a to the power of n. Meaning 2 to the power of x plus y, I can rewrite this as 2 to the power of x times 2 to the power of y, and I have this minus 2 to the power of x is equal to 120. Now, I'm going to go ahead and factor out 2 to the power of x from this equation, from my left-hand side. So now I have 2 to the power of x times, now 2 to the power of x times 2 to the power of y divided by 2 to the power of x, simply just 2 to the power of y, and negative 2 to the power of x divided by 2 to the power of x is negative 1. So this is equal to 120. Now, 120, this is the same thing as 8 times 15. And notice how 2 to the power of x, this is going to result in an even number because 2 to the power of any number is going to be even. And 2 to the power of y minus 1, well, an even number minus 1 is going to be an odd number. 2 to the power of y is going to be an even number, and an even number minus 1 is an odd number. So this is even, this is odd. And notice how 8, this is even, and 15, this is odd. So I have an even number times an odd number is equal to an even number times an odd number. So this means that both the even numbers are equal to each other. So 2 to the power of x is equal to 8. And both the odd numbers are equal to each other. So 2 to the power of y minus 1 is equal to 15. So let's first start by solving 2 to the power of x equals 8. So 8, this is the same thing as 2 to the power of 3. So now I have 2 to the power of x is equal to 2 to the power of 3. And this means that x is equal to 3. Now for 2 to the power of y minus 1, I can add 1 on both sides. So I get 2 to the power of y equals 16. 16 is 2 to the power of 4. So I have 2 to the power of y is equal to 2 to the power of 4. So this means that y equals 4. So my value of x is 3 and my value of y is 4. Alright, so in this video, I'm going to be solving the problem 9 to the power of 900 minus 9 to the power of 901. So, to solve this, I'm going to first start by evaluating my terms. So we have 9 to the power of 900 and 9 to the power of 901. And these two terms are pretty similar, except that the exponent for 9 to the power of 900 is 1 less than the exponent for 9 to the power of 901. So the easiest way to solve this is to simplify this as much as we can. And a way to do that is to factor out a term. Well, 9 to the power of 900 is actually a factor of 9 to the power of 901. So all we have to do is rewrite 9 to the power of 901 as something times 9 to the power of 900. Well, we can use properties of exponents to do this. So I'm actually going to rewrite 9 to the power of 901 as 9 to the power of 900 plus 1. And now I can use the exponential property a to the power of m plus n is equal to a to the power of m times a to the power of n. So I get 9 to the power of 900 minus 9 to the power of 900 times 9 to the power of 1. So now from here, these two terms have the number 9 to the power of 900 in them. So I'm going to factor out 9 to the power of 900, which is what I said I was going to do at the beginning of the video. So now I get 9 to the power of 900 times 1 minus 9 to the power of 1. And this is equal to 9 to the power of 900 times 1 minus 9, because 9 to the power of 1 is the same thing as 9. Now 1 minus 9 is equal to negative 8. So I get 9 to the power of 900 times negative 8. Now from here, I said I was going to simplify this as much as possible. And we can't really get the exact value because 9 to the power of 900 is such a big number that we can't actually get the exact value for that. However, what we can get is the simplified value, and we're going to simplify it as much as possible. So I'm actually going to move this negative sign to the front. So I get negative 9 to the power of 900 times 8. And this gets me negative 3 squared to the power of 900 times 2 to the power of 3. We're simplifying these terms as much as possible. So I'm going to use a quick exponential property that says that a to the power of m to the power of n is equal to a to the power of m times n on 3 to the power of 2 to the power of 900. So I get negative 3 to the power of 1800 times 2 to the power of 3. So this is my final solution to this equation. Now, if you haven't already, please make sure to subscribe, leave a like, and even show this to any of your friends and family. That would support me a lot. I have a bunch of other videos similar to these on my channel, and if you're up for any challenges, I have a bunch of those, so please make sure to check them out. And thank you for watching. Bye.